Today I will be demonstrating osmosis. To demonstrate a solvent flowing into a concentrated solution, I will be dropping 2 raisins right here into this cup of water, and these ones will not be dropped in, so we will see what happens over an hour. As you can see, the raisins are now in the water. I will now take the raisins out of the cup. It's been about an hour. Let's go. That. Come close up. As you can see, the water has soaked into the raisin's skin, and the raisin has become a pure solvent. As of here, you see how much bigger these are? These are swollen up because the water has been soaked in, and these are dry raisins. That is a demonstration of osmosis. This is also osmosis. To demonstrate the flow of a solvent from a less salty solution of the cells into a salty brine, I have 2 pieces of potato cut thinly, and then I will now put 1 potato slice in a normal cup of water, and I will now make this one a salty solution by adding 1 tablespoon of salt into this one. Now I will stir it. Mix up the content. Then I will add the other slice of potato in here in just a second. I will now add this piece of potato into the salty solution, and we will see what will happen in about an hour. I will now take the potato slices out of each cup. This one is the water cup. And this one is the salty cup. It says this potato should still be crisp because it was only soaked in water. As you can see, still crisp, not very flimsy, won't bend. But this one, because it was soaked in the salty brine, is very flimsy, bendable. This is because the slice was soaking in salt water. It is limp because some of the water cells left and went into the more salty brine. This seamless effort movement of the solvent is osmosis, captured by the expression learning by osmosis. Our third demonstration involves the decreased ability for a solution to evaporate when compared to the plain solvent. Once again, this property, called vapor pressure alone, does not depend on the chemical nature of the solute, but simply on how much the solute is dissolved in the solvent. I have 3 crushed up aspirin tablets right there, and 2 half cups of rubbing alcohol. I will now dump the aspirin tablets into the cup on the right, and I will now swirl the contents. I will now put them in the same place on the counter, let them sit for around an hour and a half, and we will see maybe a little slight difference of the levels, because this one evaporates slower than this one because this one is mixed with the aspirin. So as you can see, this cup has a higher water level than this cup. Both cups have been evaporating, but the aspirin cup over here has been evaporating more slowly from the water cup. This same effect can be observed with vitamin pills or iron tablets dissolved in alcohol. Thus, this is the presence of these solutes that causes the effect, not the nature of the solutes. This is an example of vapor pressure level. Right now I'll be demonstrating boiling point evolution. I can demonstrate this with vinegar because vinegar displays colligative effects because it is a solution of acetic acid in water. Right now, on the right side, we have vinegar. On the left side, we have water. When I start boiling them, vinegar should boil around 102 degrees Celsius and water should boil around 100 degrees. So because I'll be boiling them at the same time, you should find that water boils right before vinegar boils. So this will start boiling, and then maybe a few seconds later when it heats up a little more, that should start boiling. So as you can see, water just reached 100 degrees Celsius and is now starting to boil. And now, as you can see, vinegar is starting to get closer to 102 and it's almost boiling. Just give it a second and I think it will start boiling here. Up, 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 up. There we go. Vinegar is now boiling because the temperature is now reached to 102 degrees Celsius. And that is a demonstration of boiling point evolution. Right now I'll be demonstrating freezing point depression. To demonstrate freezing point depression, I have two bottles here, both filled with water. And now I will add 1 tablespoon of salt to this bottle of water right here. Now I will put the cap on. Swirl it around to mix the contents. I will now put them in the freezer to see, or to wait till they freeze, and as it says, this one should freeze, but this one, the freezing point changes, therefore it will not freeze in a normal freezer temperature. I have now pulled out both bottles. As you can see, you will find that water freezes as you expect, but the saturated salt solution has such a low freezing point that it will not freeze at a home freezer temperature, which demonstrates freezing point depression.